And good evening, everybody. I just wanted, John asked who was from Champaign or other areas. I want to ask you another question. Who has never had a spotter class before? If you could raise your hand. Wow. Okay, good. Good. We actually, whenever we teach this class, we usually average about 30 to 40% of the people are new to spotter training. I want to start out by saying that the reason that you are here tonight is to help your communities. Not just the community you live in or the county you live in, but all the surrounding areas, because they rely heavily on actual storm spotter reports. When warnings go out from the National Weather Service and it says radar indicated this storm could produce 80-mile-an-hour winds or a tornado or 2-inch hail or whatever the case is, most people unfortunately aren't going to pay attention to it unless the warning says somebody has cited something. If it's the first warning, not so good in most cases because nobody's probably cited anything yet. But your reports are critical to the process, to our warning process, to the process of people taking shelter, and it allows other communities to prepare. Reports from Champaign County are critical to what the National Weather Service in Chicago does, what the National Weather Service in Indianapolis, what they do. So we all work together, they see all the reports, and so we're going to be talking a lot about accurate reporting, who to report to, how to report, what exactly you need to let everybody know about. Housekeeping, first thing I want to bring up, these spotter guide booklets, we used to have them for everybody to hand out. Unfortunately, we don't have them anymore. We do have a PDF copy that you can get on our webpage. I'm going to have a handout for you that everyone can take at the break, or because we will take a break halfway through, or at the very end. It's going to have all the web pages on there for downloading information or where to get other resources, okay? But if you go to our weather.gov Lincoln spotter webpage, you can get a copy of that. And a lot of folks like to have that on their cell phone or on their mobile device anyway, because if you're out in the field and you're looking at stuff, and maybe especially if you're a first-time spotter and maybe you forget some of the terminology, you can quick bring it up on your device and look that up. So I would encourage you to go and download one of those copies. John already mentioned about the cell phone, so I'm not going to repeat that. So as far as the outline of the first half is concerned, we're going to start out with some basics as far as ingredients, some terminology that's used, some definitions, particularly as they relate to severe storms. Then we're going to go into tornadoes. In the past, we would kind of break it up and talk about multi-cells and single cells, all those different storms. We're instead talking about the different things that you are going to experience. So tornadoes and everything else that spins out there, damaging winds and hail, and then we'll take a 10-minute, 15-minute break, and then we'll come back in the second part. And in the second part, we're going to talk a lot about the challenges that spotters face, some safety tips, and a lot of other things. So that's where we're going with the training for this evening. As far as what we're dealing with, we get more severe storms and tornadoes than any other country in the world. In the United States, we average about 1,400 tornadoes every year. Last year was actually kind of a quiet year. We only had about 1,150 across the country. If you had to look at number 2 on the list, you'd either be looking at China or Canada. They get about 100 in one year. So we get a ton of these in the United States, and you also may not be aware that Illinois ranks 5th in the country for the most tornadoes per square mile. This is a statistic that the Storm Prediction Center came up with from 1991 to 2015, so some pretty recent statistics here. Kansas, Florida, then the Deep South, Alabama, Mississippi, and Illinois. Oklahoma's not in there, they're in the top 10, but we get more tornadoes per square mile than they do, okay? Not as easy to chase around here, right? Or to view storms, but we do get more tornadoes than they do, more than Nebraska, Missouri, Texas. So we get quite a bit of severe weather here in the Midwest and especially in Illinois. Now the question is why? Why do we get so many tornadoes in the United States as opposed to other countries in the world? And the main reason is because we have all the ingredients at our disposal. more so than any other country in the world because of our geography. We'll talk about some of these ingredients here in a moment individually, but when we're talking about moisture, the Gulf of Mexico is really our main source. We have other sources, but that's the main source. Dry air coming up from the southwest, low-level winds increasing from the south, bringing the moisture in. High-level winds, or what we call the jet stream, coming across. Typically, again, it's usually over our area in the spring and again in the fall. And then cool air coming down. And when you get all that combined, amongst other things, it all tends to meet between the Rockies and the Appalachians. That's really the way it's all laid out, and why we get so much in the way of severe weather. We also get more severe storms, more hail, and more flash flooding than most parts of the world as well, for all these same reasons. So let's jump into the ingredients, some of the terminology, and the development of thunderstorms. To get a thunderstorm, you need to have moisture. We already talked about that. Now, we can also get moisture from local vegetation when the crops are really doing well, particularly later June, July, August. That's when we're starting to get those very, very humid days during the summer. You know, those, we measure humidity through the use of dew point. You get dew points in the upper 70s, 80s, like last summer. Last summer was extremely humid, one of the more humid summers we'd had in a very, very long time. So you have to have the moisture. Then you have to take that moist air, you need to push it up, you need to lift it. There's a number of ways to do that. There's not just one way, there's a number of ways. The basic fronts you see on a weather map, cold front, warm front, stationary front, those types of things. Jet stream can cause air to rise. Heating of the ground, what we call convection. When you get the heating of the ground, the warm air parcels rise, cool, condense, you get the clouds and the storms. You can also get storms developing from other storms that have already formed for various reasons. We call that an outflow boundary. We'll talk about those a little bit later. The cool air spreading out from a storm, you can get more storms developing on that boundary. Some of the other ingredients you need, instability and you need wind shear. And we'll talk about those two terms here next. When we talk about instability, to get a thunderstorm, you need the atmosphere to be unstable. And when it's unstable, that means that the air is unrestricted. It can move up or down, kind of like this hot air balloon. When you add heat to the balloon, the envelope of the balloon, heat to the system, the surrounding air is cooler, so it's just going to continue to rise. Okay? That is an unstable situation. But also, you can have the air is also going to be descending as well. That's important because we'll be talking about updrafts, air going up, and downdrafts with the air coming down. Temperature and moisture content of the air, that really is what defines instability. Not just at the ground, but at various levels in the atmosphere. To illustrate instability, take a look at this time lapse of these clouds here, and notice how that cloud just erupted up into the upper levels of the atmosphere. It reached a condition where it was unstable, and it just continued to rise until it was stopped by a more stable layer higher up in our atmosphere. So instability is to get that air rising and to continue to rise and also continue to descend. The opposite is stable air. Stable air means, as the term would imply, stable. It's really not moving very much, maybe a little bit, but not very much. It's restricted to very short distances if it's going to move at all. This is what the clouds would look like in a stable atmosphere. Very little vertical growth. Flat topped. You don't have that vertical development in the storms, or in the clouds I should say, and you don't have any storms present. Why is this important? Well, it's important because when you have instability, you will get the air moving up, and we call that an updraft. The air moving up is the warm, moist air that feeds the storm. That's the fuel source for the storm. Precipitation forms in the higher reaches of the cloud, whether it's liquid water or ice up in the upper part of the cloud. Not falling through that area yet, but it's forming up there. And another key thing to note is that tornadoes form in the updraft. Okay, if you are going to be a spotter that you're looking at the storm, you've got to know where the updraft is. You have to identify that area of the storm because that's where you're going to look for tornado development. And we'll talk more about with the certain types of storms where you can find the updraft, where that's located. The downdraft, that's your precipitation that has formed. It now comes down with the gravity just brings it right on down. Wind also can force it down toward the ground, and that's typically bringing colder air with it, and we call that a downdraft. When you're in the downdraft, you're in the rain, you're in the area where you're going to get your wind gusts, or the most intense downdrafts we call downbursts. And we'll talk more about those a little bit later. Right now we're just kind of putting some terms out there. So updraft and downdraft. Both of those are extremely important to thunderstorm development, but so is wind shear. A lot of times wind shear is kind of what makes it or breaks it, particularly setting the environment as to whether or not you can expect tornadoes that day, whether you can expect mostly downdrafts with wind. In a typical situation, wind shear is going to make that difference. When we talk about wind shear, we're talking about one or two different characteristics. It either means that the wind is changing direction as you go up in the atmosphere. A favorable condition would be wind near the ground that's coming from, for example, the southeast or the south, and the wind up at jet stream level is coming from the west or maybe even the northwest. Okay, so you've got some opposing direction going on there. We call that directional shear. You can also have speed shear, which means the wind speed increases as you go up through the atmosphere. So for example, down near the ground, you may have 10 or 20 mile per hour winds. You get up to jet stream level, you may have 70, 80, 100 mile per hour winds. So that would be a more extreme wind shear. And sometimes you see both. Sometimes you see that condition where the wind is not only turning as you go up in the atmosphere, but it's increasing in speed as you go up with height. That is the difference between a typical garden variety thunderstorm and a severe storm. Here's a video showing some wind shear. Notice how the clouds here are moving in different directions. I don't know how, there we go, I'm not sure how well you can see that, but the lower clouds are kind of going from left to right. Some of the upper level clouds are kind of coming toward the photographer, and that's that wind shear condition. Just look at the clouds. Look how the clouds are moving to determine whether or not you've got that directional change in the atmosphere. So the clouds can tell you a lot. Not only the direction, but the speed. Wind shear is important because wind shear is also going to set up where the updraft and downdraft are located within that thunderstorm. If the updraft and downdraft are really close to each other, what's going to end up happening is that storm is going to have a shorter life cycle, because the cold air, the rainy air, falling down very close to the updraft is going to kill that storm. It's like cutting the gasoline to an engine. The warm updraft is the fuel for that thunderstorm. You cut that off, your storm's going to die out. An average single cell thunderstorm lasts for about 45 minutes or so, 45 to 60 roughly. Supercell thunderstorms, though, on the other hand, the updraft and the downdraft are separated more, and that's what allows these types of thunderstorms to continue for many hours, until you get a condition where something changes in the atmosphere, allowing that updraft and downdraft maybe to get a little bit closer, or some cold air gets drawn into where the updraft region is. Then that storm will finally die out. But that could take a very long time. So weak wind shear, they're close together. Storms are short-lived. Strong wind shear, they separate more, and as the storm moves, it can continue for quite some time. With strong wind shear, you also get a condition where you can get horizontal rotation that develops near the ground. So it's causing this, the difference in direction is causing kind of a rolling motion from the ground, and that we're It's raining pretty good now, yeah. No, this is great, yeah. Perfect timing. Now we just need a little thunder, right? No? Okay. Damn, couldn't get it on cue. All right. Anyway, we get this horizontal rotation developing near the ground because of wind shear, right? The updraft, as the storm approaches, can pull some of that horizontal rotation into the vertical, and now the updraft has a rotation in that area. That is a chamber, an area where tornadoes can develop. We'll tell you the term about that a little bit later, but I'm just introducing the concept of wind shear right now. But the rotating updraft is associated with your supercell thunderstorms. Some visual clues. Like I said, you got to look at the clouds. The clouds can tell you an awful lot. When the storm is farther away, you're not going to see this necessarily when it's right on top of you. But when the storm is farther away, look for the overshooting top. I've got it circled there in green. That's an indication of an intense updraft. This area right here is what we call the anvil portion of the cloud. That's a very stable layer in the atmosphere. It restricts upward motion. If you're pushing up through that stable layer, you have an intense updraft right there. You get a little cap on top of that. That tells you you are dealing with a severe storm. One thing that we've noticed just from observing these is that if this cap up here, if this overshooting top persists for about 10 minutes or more, that storm continues to strengthen, and then once that top collapses, and if you watch it, you can actually see it starting to come down, severe weather right under that storm is imminent. And in many cases, they end up getting tornado development near that time as well. Now again, this is not affecting you necessarily right where you are, but it can give you an idea of what the atmosphere is capable of with storms in that day. Another thing to keep an eye on, the updraft here, the main storm tower. It might be a little tough to see here, but notice how the clouds in here, they have very distinct edges. They're not fuzzy looking at all. Okay, it looks like clusters of cauliflower all kind of pushed together. When you have that condition right there, that's an indication of an extremely strong updraft as well. You have a very intense storm tower. The other thing with the anvil, if this storm is moving left to right, for example, in this case, if the anvil is going back farther toward the west, we have a term for that. We call that a back-sheared anvil. That basically means it's opposing the jet stream, and the higher level winds are wanting to push the storm in this way, but the anvil force is going back that way. That is another indication of a very intense thunderstorm. Okay, let's jump into tornadoes and everything that looks like a tornado and might be a tornado and anything that spins. This is going to be really the meat of the first half here. So we already talked about this with this rolling motion where it gets pulled up by the updraft of a storm, stretched, and now that updraft will obtain rotation. We call that a mesocyclone, or a meso for short. The meso or mesocyclone, that is what we are witnessing, what we're experiencing on the Doppler radar. Okay? In most cases, our Doppler radars are not seeing the actual tornado. It would have to be awfully close to the radar to be able to see the tornado and the rotation associated with it. But we're seeing the mesocyclone, which is very important and can be important to tornado strength. Many times we see this mesocyclone quite a few minutes before that tornado develops with some storms. There are exceptions, and we'll talk about some of these exceptions here a little bit later. It's hard to actually see the rotation of a mesocyclone because it's so large. Even some of the smaller mesocyclones might be about a mile across or so, give or take. Some of the larger mesocyclones can be 3 to 5 miles across. If something's that wide across and you're fairly close to it, it's going to be difficult to actually see like a spinning motion. But again, look to the clouds. You can see the curvature, you can see the banded nature of these clouds, indicating that rotation most likely is occurring in that area. We've seen this through time-lapse photography, where we are noticing the rotation, and I've got a video here in a few moments to show you with respect to that. There's a couple different kinds of storms with rotating updrafts that impact us here in the state of Illinois and the Midwest. The classic supercell and the high precipitation, or HP supercell. Classic supercell, this is kind of your textbook supercell. We'll show more images of that here in a moment. The HP supercells, we'll show these too. We'll talk about those because we get quite a few of those. These are very dangerous for spotters. You can see the banded nature of the clouds, but it's very difficult to see any low-level rotations in there because you're being blocked by rain that has wrapped itself between you and whatever rotations might be occurring. But one of the things that we want spotters to report is a wall cloud. A wall cloud is a lowering near the updraft. Many of these rotate, some do not. There are some wall clouds that form and they just don't have rotation, or very subtle rotation that's hard to detect. But the ones that are more capable of producing a tornado, you're going to see, again, not spinning like a top, but it is going to be a gradual counterclockwise rotation that you'll see with that. So the key is the rotation, and these are usually long-lived. Again, every storm is different, but we have had spotters tell us, you know, I watched that wall cloud for 10-15 minutes before a funnel cloud developed or before the tornado formed. So wall clouds are persistent. They can be there for quite some time. Other wall clouds will be there for several minutes and then just dissipate or reform somewhere else in the storm. So the key is you see the rotation with those, report those to us. You often will see upward motion because this is where the updraft is located. Cloud fragments and moisture you may see actually getting drawn up into the storm. If it's very dry and windy, you may actually see dust from fields getting drawn up into the storm and right up through that updraft. Sometimes these wall clouds have a tail cloud, which is this part right here. That's, again, it's drawing some of the moisture, and because of the rapid upward motion there, it creates this cloud that kind of looks like a point toward the end. So here are a few wall clouds that photos people sent us from the last several years. We got a wall cloud right over here. It's quite a distinct lowering in most cases, and they're not near as wide as the whole rotating updraft, the whole mesocyclone. They're quite a bit more narrow. Here's another really good example of a wall cloud. The rainy area is off over here. This tells me with this storm here that the photographer is behind it. The storm is moving away. The rain here is probably moving off to the northeast or east, and this is on the west side of the storm or southwest side of the storm. Very ominous looking, low hanging wall cloud. This one here was, and you're going to see a lot of these photos from December 1st of last year. That was our biggest severe weather day last year in the state of Illinois. And we've seen a lot of that lately, where our biggest severe weather day tends to be in December, February, November, some of the cool season months. But this particular one here, very low hanging wall cloud. There was a lot of rotation going on here. In fact, right after that photo, a tornado developed right within the vicinity of the wall cloud there. Another wall cloud here, again from the December 1st storms out in western Illinois. Wall cloud here hanging pretty low. Again, this shows some of the storm structure here. You've got the updraft here. Notice how the clouds have that billowy look to them. They're not fuzzy looking clouds at all. Off here in the distance, you have these white streaks. That's hail. We call that a hail shaft. I'll show you more pictures of those a little bit later. But there is hail that is literally pouring out of that storm. A lot of these supercell storms can produce very large hail in large amounts. Here's a video that we have, a time-lapse video of a wall cloud. Actually, we have a feature right here. It looks like something also is trying to form in this area here. It looks, as you see this video go on here, it appears that these two kind of combined forces here. This left to right movement here, since this is time lapse, this is your larger scale, your mesocyclone, your rotating updraft right in here. You see you've got rain off in this area here. It's your downdraft area. Your updraft area is over here. When we're talking about funnel clouds, the key thing with the definition of a funnel cloud is that it is not yet reaching the ground, okay? It's not reaching the ground. If it's a funnel cloud, it's a narrow, rotating column of air in the vertical, spinning, and this one you will see rotate fairly quickly. We'll see some more of these. In fact, here's one right here. Oh, Andrew, are you here? Is Andrew in the room tonight? I thought maybe he might be here tonight. I don't see him. Okay. You're going to see a lot of pictures from Andrew Pritchard. There's a lot of folks from the Champaign area that follow these storms in various parts of the state, and Andrew sent us a ton of pictures. These were very photogenic storms. This one here, you can see how low the funnel is toward the ground, but again, there is no connection with the ground. There is no rotation at the ground, no debris being lofted, so that is a funnel cloud, okay? What we don't want to hear is a spotter reporting we have a funnel on the ground, okay? That's called a tornado, okay? A funnel on the ground is a tornado. So here's a video showing the rotation of a funnel cloud right here, and also some of the rotation that's occurring within that storm. Again, you'll notice in many cases these funnel clouds are fairly persistent features. They'll change shape and they look like they're going up and down and reforming and whatnot. But typically you will find that funnel cloud in the vicinity of the wall cloud or coming out. We've seen them out the sides of wall clouds, but generally it's going to be in the updraft area. That's the key point. See, here's where it's starting to reform again a little bit. So you see something like that, report a funnel cloud, but again, it's not in contact with the ground. Once you see ground contact, then you report a tornado. And there is the definition of a tornado. Extends from the base of the cloud. Here's the key, the base of the cloud, and it's in contact with the ground. We are going to see images of rotations near the ground that are not connected to the cloud. Those are not tornadoes. But here's our definition of a tornado. Now, one thing to note, I think a lot of spotters realize this, but I want to point this out anyway because a lot of people in the public don't. A tornado is not a solid object, okay? A tornado doesn't just go bashing into things, and tornadoes don't bounce around, okay? They don't have springs moving around. It's air. It is air, it's wind that's rotating along a vertical axis in contact with the ground and extending up to the base of the cloud. Therefore, they start out nearly invisible near the ground because you need to pick up some debris here near the ground. The air rising up through here has to cool and condense to create that classic tornado look when it's first forming. So when they first start, this is kind of what they look like. Now again, they're all different. Tornadoes are like people. Every single one of them is different. They may form similarly, but they're different. Some of them form very quickly. Some of them, you know, you see rotation at the ground. Next thing you know, the whole thing's filling in and you've got that classic tornado look. Others, you may not see that classic tornado look through the entire life cycle of the storm, and you may just see a bunch of dirt or debris raised here to a certain level, but there is a connection here, and once that connection, or I should say once the connection is made, that's when you have your tornado, okay? Now, some of the variations of tornadoes that we deal with, first of all, supercell tornadoes, whether it's the high precipitation or the classic supercells. You've got all the ingredients. You've got typically pretty high wind shear, your instability, it changes seasonally, but typically these are going to form when you've got large levels of instability, particularly in the lower part of the atmosphere. The rotation with supercell storms is going to extend quite a ways up through the storm. The visible portion here of the tornado is very low, but that whole mesocyclone rotating updraft can go many thousands of feet up through that storm. Oftentimes you'll see the wall clouds and funnel clouds prior to tornado formation with a supercell storm. But keep in mind that these storms also produce very high wind gusts. You're not just going to have, like, oh, there's the tornado with no wind around it. The wind to create it, that what we call a rear flank downdraft, we'll talk about those. I'll show you some examples of that. You can have very high wind speeds in that area. So your downdrafts can have wind speeds of 60, 70, 80 miles per hour. Supercell storms produce very large hail. Typically, the supercell thunderstorm will produce hail the size of a golf ball or larger. Very few storms can produce hail that big or even bigger. So you're dealing with a supercell if you have large hail like that. Here's kind of the classic radar view of a supercell storm. Here is the tornado right here in west central Illinois. This is what it looked like on radar. The photographer was east of the Illinois River here, looking back up toward the northwest. If you follow on the radar, we call this the reflectivity. That's all the rain and hail and cloud matter and stuff that the radar beam's bouncing off of. If it kind of comes to like this backwards J, like a hook, or in this case there's a ball on the end of it here, we call that a hook echo or debris ball in this case. That's an indication of the rotation with the mesocyclone that's going around in that storm. It doesn't necessarily mean you have a tornado, but you do have a mesocyclone with the storm. This is why spotter reports are so critical to let us know at the Weather Service that, yeah, there's something occurring underneath this. We have to be kind of discriminate, because if I issued a tornado warning on every single mesocyclone that was on storms, only about 10 to 15% of them actually produce tornadoes. The other 85–90% do not. They'll produce large hail and maybe some wind gusts, but not necessarily the tornado. So this is where the spotter reports really fill that gap. So if I've got an environment like this, I'm showing some, hook echo on radar, and a spotter says I've got a rotating wall cloud, yeah, you can bet we're probably going to put out a tornado warning on that storm. But at any rate, this is what radar would look like. We're going to show quite a few radar images, because this year we really want our spotters to use radar as best as they can. Again, I'm not trying to turn you into radar operators, but I want you to at least understand the basics so that you can use it to be an effective spotter. Another example or product to use would be a velocity image, or what we call a storm relative velocity image. You need to know here that in most radar software packages, the warmer colors, your reds, oranges, yellows, that's wind going away from the radar. Green and blues, your cooler colors, is wind coming toward the radar. If you have a high wind speed going away and next to a high wind speed coming into the radar, you've got an intense circulation over there, and especially if it's persistent. Don't just look at one radar image and say, oh look, there's a rotation, I think a tornado is going to develop there. Look for consistency with that storm. But it can also help you determine what you might be looking at if you're kind of unsure if you're out in the field. So combine what you're seeing with your eyes with what radar imagery is showing. So in the developing stages of the classic supercell tornado, we see this image here of a wall cloud starting to form. Notice you've got the rest of the base of the storm right here. But a few moments later, you'll notice that the base of the storm looks like it's risen, and the wall cloud is fairly distinct here. Now we have a funnel, but notice how there's kind of a bright area here. This is that what we call rear flank downdraft. That's the air that's coming down, and that descending air is kind of eroding the cloud over here, and that's why it looks like it's rising and a little more bright, a little clearer over there. That can tell you a lot, because what we know from tornado research is that when this comes down, this rear flank downdraft comes down, You have another downdraft coming from where the precipitation, where the rain is occurring. We can't see that in this image, but when you got those two downdrafts getting very close to where this updraft is, the combination of those is going to get the motion going near the ground to get that tornado to develop. Everything's got to be just right. You have to have the right temperatures. It's almost impossible to measure any of this stuff, but we want our spotters at least to be aware that when you see this, watch very carefully that, okay, this funnel cloud is about to become a tornado. If you see something like that, you got to watch real close because it can happen quickly. Here's a separate tornado, different one from out in Kansas. We have the wall cloud here, very distinct funnel. But we're going to look here, especially toward the ground, to see if there's any debris being lofted or any rotation that we can see there. Don't see any quite yet, but a couple minutes later, now we see it. We're starting to see right here this debris that's being lofted right near or underneath the funnel. That is the very beginning of our tornado. The mature stage of the tornado, I mean, tornadoes are dangerous, period, but this is the most dangerous portion. This is typically where you've got your higher wind speeds. A lot of times tornadoes will become quite a bit wider after they've been on the ground for a period of time. Notice it's a little tough to see with the lighting, but here you can see kind of a bright area right here. Again, that's that rear flank downdraft that keeps coming down and kind of wrapping toward the circulation of the tornado. That's the mature stage. Oftentimes too with storms, they'll raise so much dirt and debris that you can lose sight of the tornado itself. And you may not be able to tell from your vantage point whether or not that tornado is still there. It just looks like this big, cylinder of debris. Eventually, the tornado will go through the dissipating stage, the rope stage, and when this happens, all the air, or vast majority of the air that was moving up through this rotating updraft has been cut off. And now we have mostly the downward moving air with the rear flank downdraft. The updraft is way off over here somewhere, and this eventually is going to wind down. This is going to get narrower, and it's going to decrease in intensity and eventually dissipate. And we'll see in a series of pictures here how this tornado just eventually dissipated here. Still, you got a bunch of debris and stuff that's falling out and settling, but the tornado there is done. The thing with classic supercells that you got to be careful of is many times they often produce more than just one tornado. They'll be what we call cyclic supercells. They'll produce a tornado, go through this kind of a recycling, and then they could produce another tornado. Here's a case where we have a classic supercell looking to the northeast, so it's kind of moving away from the photographer. We see a tornado here. If a new tornado were to develop, it's going to be somewhere off in this area right here. And as we move ahead in time, we see how the tornado is very narrow in the lower, a few hundred feet here. Still got quite a bit of rotation going on upper parts. But we're getting a lowering off to the east to northeast, maybe a funnel starting to develop in here. And a few moments later, this tornado is starting to go through the dissipating stage, and a new tornado would be forming right over there. Sometimes, that separation could only be a few miles, if that. We got a perfect example from the Taylorville tornado from December 1st. Here's a 12-minute radar loop showing how a classic supercell on radar went through this, where one tornado dissipated and the next one formed. So here's the hook echo working its way up toward Taylorville. The tornado is now hitting Taylorville. See the debris ball there, and it's as it's moving out, so the last image we have in this loop, you'll notice it looks like right here we're starting to develop what appears to be maybe another hook, another kind of mesocyclone rotation. When we look at the velocity image here, we confirm that by seeing right here rotation with the storm, with the tornado, but we're starting to see increase in inbounds right here, and we're starting to get a new rotation right there that lines up with the new, what appears to be a new hook echo, okay? Right there. Those two line up. So you can combine radar images to take a look at this. Again, I'm not trying to turn you into, you know, okay, you got to be this expert radar analyst, but you can use this to really help determine, number one, what am I looking at, and number two, is there something else that could develop? Because in this case, you're focused on this tornado and it's dissipating right there, but a new one's forming, and that's exactly what happened. When the new one formed, it went off and it went into the village of Stonington and did quite a bit of damage there. In fact, this one storm, I talked about how supercells, classic supercells, can last for quite a period of time. This one thunderstorm produced, what did I got there? 13 tornadoes. From just east of Edwardsville, Illinois, up through Litchfield, up into Taylorville, all the way up to just northeast of Bloomington Normal. There was another supercell that went up the Illinois River the very same afternoon that produced 9 tornadoes. There were 29 tornadoes that day in Illinois. 22 of them were just from 2 storms. That was a huge outbreak. 29 tornadoes, 3rd biggest outbreak in Illinois history any month of the year. And that occurred December 1st. So again, spotters, be prepared any time of the year. High precipitation supercells, these are tough. These are really difficult to spot. They're dangerous because there's so much of the lower atmosphere that's obscured by rain. You've got this portion right here with, this is your rotating updraft in this area, maybe hints of what could be a wall cloud over here, but you see how the rain here, this rain curtain is coming around that rotation, and it's blocking your view. To get a better view, you'd have to look at it from that standpoint. The only problem is that is moving toward you. Very dangerous situation. Thankfully Roger got out of there, but he knows what he's doing. He works at the Storm Prediction Center. But wall cloud here, rain wrapping around here, where you would typically expect that rear flank downdraft area. But these supercells are aligned. The shear is different so that you get more rain wrapping around. Your hook echo is not this little skinny backwards J, it's like this huge blob of rain. In fact, here's what they typically look like on radar. Here's one, not from this area, I think this was down in Kentucky maybe or somewhere, but they kind of look like a kidney bean shape. And when you're wanting to look for any rotation, it's typically in this notch area right here. The reflectivity, the rainfall area is a little bit lower in there, not as much rain. Remember, the updraft has little or no rain. Notice how you've got this little appendage here kind of hooking up like this. This is most likely where your rotation is right there. Sure enough, that's where we're seeing the rotation. Not really intense, not strong rotation with this particular storm. But again, combining radar images, because sometimes it can be difficult. You don't want to just get caught on looking for hook echoes, okay? Because we don't always get these classic supercells. So you got to be careful with this. There are exceptions. These HP high precipitation ones are tough for spotters. Here's another example of one. This is Gifford, Champaign County, November 17th, 2013. Right here, we're looking at this and we go, well, all right, no real clear feature. I mean, we might have a notch here, might have something going on back in here. That looks like maybe that's something that's developed because it's coming around. There's a lot going on in the reflectivity there. At this location right here where the star is, Jesse took this picture here. Wedge tornado about 1.5 miles to the north of her, so the tornado is right up in here. You wouldn't expect that just looking at the reflectivity part of that image. But when you look at the velocity image, there it is. Very intense inward rotation coming toward Lincoln, toward the radar. Outward velocities, very high speeds. The tornado is right there. When the tornado went into Gifford, that rain had come around the tornado and nobody saw it coming. It looked like a wall of rain. Didn't look like a classic tornado presentation. So these can be very difficult. These are what we call the rain-wrapped tornadoes, okay? So she took that picture at 12:51, and you can see as she was taking her pictures, here's another picture here at 12:52. So you can see here this wedge tornado here, but it's getting darker in this area. That's the rain that's starting to come around, and 1 minute later, where's the tornado? It's, you know, somewhere in here. You can still kind of make it out a bit in this area, but again, the rain is starting to wrap around that. That's a classic high precipitation supercell. Here's a video showing a supercell that starts out looking like a classic supercell. Zooming in on some of the lower rotation there, funnel trying to form. We jumped ahead in the video to show, here's the rain now starting to wrap around it. This is becoming high precipitation as the rain wraps around. Totally lost, it's somewhere in there. Don't know where it is. Again, as a spotter, don't go digging around in there trying to find it. It's dangerous. Yeah, you don't want to get too close to those things. So again, just tell us what you last saw, what you're reporting. That's good enough. A lot of times with these, we'll see a pretty decent rotation on radar to just say, yep, we're just going to go with a warning on that. Some other variations of tornadoes. You don't get tornadoes just from supercells. You can get tornadoes other ways as well. You can get tornadoes with a line of thunderstorms. You got some high shear and some decent instability. We might see some rotation on radar, but these types of linear, or what we call quasi-linear type storms, it's hard to get pictures of these tornadoes because they occur so quickly. And typically after they form, you get the downdraft or the downburst of wind that blows through, and sometimes we've had eyewitnesses tell us that, you know, there's the tornado and right behind it here comes the strong downdraft from the line of storms, and the tornado just gets blown apart, dissipated. So it's difficult for spotters to see these at times, but there's a few, again, clues that you can use. They can produce damage up to EF2, which, to put it in perspective, that's going to take, you know, the roof off of a house and completely destroy an outbuilding, that type of thing. But they're usually not as long-lived as the supercell brothers and sisters. Here's some radar reflectivity showing the areas you want to look for. Where there's a break in the line, like in this example, around the Quad Cities, maybe a little kink in the line like this. Any one of these breaks or kinks in the line is an indication of where there is some low-level rotation that might be going on in that area to enhance where a tornado could form. Or the storm on the very tail end here is also one that, and sometimes the one on the tail end kind of looks like a supercell because it's getting all the good ingredients there. Here's what I was talking about with this kind of almost linear type of storm. Zoomed way in, notice how the line of storms is like this, and then it kind of kinks back in and comes back around. When you look at the velocity image, you get a little bit of wind going away from the radar toward the radar. These rotations are not very deep. They don't last very long. So usually when they're looking strong enough or more impressive enough at the Weather Service, when we see these, if we're going to put out a tornado warning on this, if we wait too long, that tornado's already developed. These are very quick developing situations. So again, spotter reports are really critical as to what might be going on with these. Love this picture here because you've got a line of storms coming through. Notice how this portion of the storm is pushing out more, bulging out more because it's you got some higher wind in here. But notice how it kind of wraps around like this and goes back. That on radar would show up as like one of those kinks in the line. It's kind of rare for spotters to get an image like this. I've only seen a couple images like this. But this would be an area where a tornado developed. Now I don't think we had a tornado develop that day with this line. There was some pretty high wind gusts with this, but this is definitely an area that a spotter would want to keep an eye on if they saw something like that. Landspout tornadoes, to be perfectly honest with you, I hate these things. No lead time on these things. These are really hard to get lead time out for people. Typically what happens is you get a front. You got this kind of east-west, usually an east-west front, and you got wind coming up from the south on one side, wind from the north on the other side. So as a result, you're getting some of these rotations like the image shows here. Because of the opposing wind flow, you can get these rotations that kind of move along this front. As you get a cloud that develops, I'm not talking a storm or even a rain shower here, I'm talking just a cloud, a cumulus cloud, starts to form on that line. The updraft, the upward moving air in that cloud can pull some of this little bit of rotation near the front into the vertical, stretch it, and you get these what we call landspout tornadoes. Once you get a thunderstorm or even a decent rain shower with this, tornado's gone. No more tornado. Because now you mainly have downdraft air with the rain. You still got a little bit of an updraft, obviously providing the fuel for that thunderstorm, but it kills off that type of tornado. They don't last too long. Sometimes they're nearly transparent. Here's two of them near El Paso, Illinois, 5 years ago. So they often occur in multiples. Another one, same day. You can barely make out the connection to the cloud. Once it fills in, this is the very beginning of this one, because once it fills in with some of the dirt and debris that it's picked up, and as this air continues to rise through here, and you get the cooling and condensing of the air, then you get the cloud part associated with it. We're pretty sure too, just because of going back and looking at records of these, here in Illinois, we have a season for these things. They mostly occur from late April through June. One of the theories behind that is because in order to get this, you need to have this flow with very little friction coming over a flat surface where the two can meet and create these circulations near the ground that can get sucked up into the updraft. Once the crops start growing a little bit taller, you don't get that smooth flow. The flow is up and down and kind of all over when the corn is, 6-7 feet tall. So when the corn is still pretty small and the bean fields are just starting to come out or have been planted, we see more of these than other times of the year. So got a video of one here. Yeah, this particular one. Notice how it looks almost transparent in the middle there. Key thing here too, you whip out your phone, you look at your radar app, what are you going to see? Nothing. You might see this tiny little blue blip showing, maybe a portion of the cloud. You're not going to see any rotation with it. So spotter reports for these are critical. We have methods where we can look at the front and say what area of the front might be conducive for these things to develop, but I'm not going to put out a tornado warning that covers 10 counties for 3 hours to say you might get a tornado somewhere in there. We rely on the spotter reports to let us know what's going on with these landspout tornadoes. Other rotations, gustnados, these are not tornadoes. They form on gust fronts. Gust fronts are these outflow boundaries. That's the thin blue line here that pushes out from a cluster of thunderstorms or just a thunderstorm. Anywhere along here you can get these rotations that spin up, but they do not rise up to the level at the base of the cloud. Okay, usually it's just a few hundred feet off the ground. And they form because of the intense wind with the downdraft pushing through, and as a result you get this little swirling dust, little swirling wind near the front end of that gust front. I see this often when I'm out traveling and it's a dry day and you get behind a semi truck and it's going fast along the side of the road, and then this little swirly of dust or debris, whatever's on the side of the road, comes up. That's kind of what's going on here. The wind is gusting out, and it just swirls a little bit of the air in there and creates a little bit of a rotation. That's not a tornado, though. There's absolutely no rotation up in here. It's all right near the ground. Cold air funnels or non-thunderstorm funnels. Sometimes we get these funnels that form not because of cold air aloft, but there's other reasons going on here. These almost always develop in the afternoon and early evening hours. Again, no rotation on radar. They rarely reach the ground, but these funnels can be very thin and extend a long ways to the ground. It looks like they're going to touch down. You know, this is the one that lights up the switchboard at the 911 center, because people are like, oh my gosh, we got funnels everywhere, sound the sirens. And they often occur in multiples too. You don't often just see one of these. We got this video here, this guy shot around Stonington a couple years ago. He's got a couple of them going on here. The typical setup for this is usually you've had storms the day before or the evening before. The morning starts out sunny, and then you start getting a whole bunch of clouds developing in the afternoon. And as a result, all that, again, upward motion, lots of instability up here because the air up here is very cold, a little, relatively warmer down below, and you get these funnels. Again, they're not associated with thunderstorms. You might get a little rain shower with it at the most, but there is not a thunderstorm with these. Okay. So before we finish up, take a break here, let's jump into damaging wind and hail. With downbursts, we need to define these first. A downburst is an intense downdraft. It's rain-cooled air that rapidly descends in a thunderstorm and makes impact with the ground or ground-based objects. You can get very severe wind gusts out of these. Most of the ones we get in Illinois occur with very heavy downpours. So they're the wet, we call them wet downbursts, wet microbursts. So they're accompanied by very heavy rain. They can last for several minutes. You can get wind gusts, very high wind speeds for several minutes. And then oftentimes what spotters and chasers that experience these things will notice is that sometimes the wind will just rapidly switch direction. Say you've got wind coming from the west here, and as it moves on, then you get the wind coming back from the other direction. You can get some very high wind speeds out of these, generally 60 to 80, but you can get well over 100 miles per hour with some of these downbursts. Love this picture here, showing a series of heavy rain downbursts that are making impact with the ground and producing very high wind gusts. Andrew took this picture here a few years ago. Very heavy rain here, making impact with the ground, and notice how it curls up here. The highest wind speeds are right through here where the impact is. But as I mentioned, as the downburst moves, let's say from left to right in this image, the wind direction will switch. Because what happens is when it makes impact, it comes down and it kind of goes, it fans out and it curls out. The front edge is, moving with the storm. It's going to have the highest wind speeds. You're going to get some high wind speeds actually opposing, going back the other way too, because of the impact that it's making back here. Squall lines, your best visual clue with a line of storms, or squall lines as we call them, is going to be what we call a shelf cloud. That's that cloud on the leading edge of the storm, and these shelf clouds oftentimes will extend across the horizon. Notice how you have some very low, ragged looking clouds here near the bottom of the storm. Your updraft is right here at the front side as it's approaching you. Oftentimes you'll feel the wind at your back or some angle feeding that storm. And remember what I said about tornadoes forming in the updraft. If you're going to get an updraft or a tornado in the updraft, it's going to be right here near the leading edge. Okay? The other thing, here's your downdraft, that's your heavy rain. This is where your high wind gusts are occurring, right here. But take note of these clouds up here. Notice the banded structure right here. That's an indication of the speed of the air, the updraft, going up on the leading edge of that storm. It's going up and back through that storm. That can tell you a lot. This image here, low-hanging shelf cloud here. Notice the banded structure of the clouds above it. That's going to indicate very high wind gusts. Another one, ominous looking dark clouds here. All the rain and wind that's occurring back in this darker area. Above the shelf cloud, you have these banded, several bands of clouds above it, again indicating the intensity of that updraft going through that storm. Here's one with a shelf cloud pretty much directly overhead. This was a day when we had a lot of high wind gust reports. You don't see the banded nature of the cloud simply because the photographer is essentially right underneath the leading edge of it. But you notice how it's you've got your rain over here and your wind would be right with that. Love this picture here. Taken at night. I jumped ahead. All right. This picture here is showing, notice the curvature here. And remember I talked about how when you've got a shelf cloud like this and then it kind of curves in like that, you want to look there for rotation. The person who took that picture was right here, I believe. Yeah, right there. Look at that. He caught that part of the cloud, and that's where rotation, you want to keep an eye right there. A few moments later, I think it's about 10 minutes later or so, it comes through. We still have that kind of notch area right here. Didn't get a tornado that was reported out of it, but you'd want to watch for rotation in that area. The other thing I want to point out, sometimes people, they hear that these storms, produce straight line winds. I really don't like that term because the winds don't all go in a straight line. They can come from different directions with these lines of storms, but they can also come with varying speeds. You could have 50-mile-an-hour gusts here, but it could be 70 here and 50 here and 40 there. I mean, they're going to vary along the line. The entire line is not going to produce, in most cases, that same wind speed. Now, some non-severe storms, still kind of, rather ominous looking clouds. You got some low-level clouds here. Here's your kind of a weaker shelf cloud. You don't have that banded structure above it. You had about 40 to 50 mile-an-hour winds with this one. This one here had 35 to 40 mile-an-hour winds. There's your shelf cloud, not as well defined. You don't have all the banded structure above it. Same thing here. Low-level shelf cloud here, a lot of ragged clouds below. Wind gusted to maybe 45 miles per hour with this one. Again, you don't have that banded structure all the way up through the storm. The updraft is weaker, the downdraft is a little weaker. I want to bring up this definition because these happen from time to time, derechos. Essentially what these are is this is a squall line on steroids. This thing is going to go and go and go at least 250 miles, but they often travel much farther than that. They typically have wind gusts greater than or equal to 75 miles per hour or higher. There's just it's one of these self-propagating type systems that just can travel halfway across the country. In fact, we typically see about one a year in the Midwest, about every other year or so as you get a little bit farther out toward the East Coast and the Great Lakes area. But here's one that developed near Chicago, and look how this thing went across Ohio, West Virginia, all the way to Washington, D.C. Tracked 800 miles, over 800 miles, 18 hours, a lot of damages, 3 billion in damages. These we typically see in the late summer, or right in the summer I should say. June, July is really kind of the peak time for these, which is also critical because a lot of times these are followed by extended heat waves. If you've got an extensive line of storms that has created massive power outages, and you got some areas that may not get power for over a week, and now you're talking a heat wave behind it, you start increasing the fatalities, the impacts of that storm. One thing to keep an eye on is the verbiage in the warnings. You don't often see in Weather Service severe thunderstorm warnings 80-mile-per-hour wind gusts. Check down here. We always have this wind tag that'll show the expected wind gust and what some of the potential impacts could be. In the second half, I'll show you where you can get text product information on these. Last thing here is hail. The way hail forms is you get the precipitation that's falling out of the storm above the freezing level. It's mostly ice or water-coated ice, and as it's falling through the storm, some of this can get caught right back up in the updraft, and it takes another trip right up through the storm, gets another coating of water and ice, and it can just keep going, and it's based on the strength of the updraft. So imagine if you get a hailstone that's the size of a baseball, or probably one of the bigger ones that I've heard of around here, you know, grapefruit or larger size, solid chunk of ice the size of a grapefruit. How much wind does it take to keep that elevated in a storm? About 150 to 200 miles an hour, roughly, to keep that elevated. Eventually, gravity takes over, and it's just going to fall out, or the storm updraft is so strong it'll actually shoot it out of the storm, and you'll get large hailstones that end up falling in the downdraft. We got some, this was a huge hailstorm not too far away, Tuscola, May 21st, 2014. Hailstones bigger than baseballs, a lot of damage. I think the damage was estimated over $100 million. And Tuscola is not that big of a city, so to have $100 million in damage, that was intense. And there were a couple of injuries there too. People got beat with hailstones. Canton had a large hailstone or hail storm with baseball-sized hail a couple of years ago. So again, remember, if you hear about golf ball or larger hail, especially larger than golf ball, you got a supercell on your hands. If you got a supercell, large hail, strong updraft, you've got the potential for a storm to produce a tornado. There's some of the damage in Tuscola. Oh, look at that Mustang. Jeez. That's terrible. You worked on that car? Yeah, that's terrible. The other thing spotters may see, and we pointed this out in one of the earlier images, but here's another example. This white streak coming down from the storm, that's a hail shaft. It's a concentrated area of hail that is coming down in the downdraft below that storm. Again, if you see something like that, really useful information for us. Here's one of the hailstorms we had that was in Fulton County a couple years ago. Look at the radar reflectivity. This is a supercell. It's kind of got this V look to it, this V notch here. A little bit of a hook, not much of one, but very intense reflectivities here, which tells me we've got some very reflective, probably large objects. Water-coated ice is very reflective on the radar. And what confirmed that for us was that we saw these spikes of lower reflectivity right downstream from the radar beam. That tells us, yeah, that's definitely hail. Some radar programs can give you an expected hail size or a maximum hail estimate. This is the GR Level 2 program. This was showing the pink colors indicating 2¼ to 2½ inch hail. That's exactly what they had with that storm. They had tennis ball to baseball size hail with that hailstorm. Didn't get a tornado out of it, but they did get quite a hailstorm near the city of Canton. We're going to start out talking about some of the spotter challenges that you're going to face. Again, we're doing this a little bit different than what we've done in the past because we get feedback from spotters and emergency managers, and even in the office there in Lincoln, we talk amongst ourselves and say, you know, here's something that we need to talk to the spotters about. So we brought up a few things in there. Then we'll go into awareness and safety, how to prepare for activation, some of the information you can use to be better prepared to be a spotter, how to stay safe while being out there spotting. That's really the meat of the second half. And then we'll finish up with effective reporting, because we always say this, if you see something and you don't report it, you're not helping anybody, okay? Maybe you're getting a great picture, a great video, or something like that, but you're not helping anybody in the community that needs that report to take action for safety. So we'll discuss that. So first of all, with some of the challenges, I got a question for you on this one. Is this a tornado or is that a funnel cloud?
Can't see it.
Can't see it. Can't tell the tree line. Remember, we talked about how this could be a tornado, but is there any rotation going on at ground level near here or just above the ground? We can't see it because of the vantage point of where that spotter is. We don't see any debris being lofted at the moment. So what I would encourage you to do is, if you were in this position and you could not move for safety reasons or just because of the way the roads are laid out, you can't get a better view with that tree line there, what I would ask you to report is, report that you have at least a funnel cloud, but you cannot see what's happening at ground level. That is an enormous amount of information. That helps us a lot, okay? So report that. Now, I will say this is probably a tornado, and the only reason I say that is you got this clearing here. You got that rear flank downdraft that's coming down, and you're getting kind of that clearing. And when we see that, that's typically when these tornadoes are going to start developing. A tornado actually was in the process of forming right when this image was being taken. This was a very photogenic storm. We had a lot of spotters and chasers watching this storm near Beardstown, Illinois. You're going to see more images of this storm in the next few minutes. But from this vantage point, we can't tell. So obstructions to your view can be a challenge. There's another one. John Dwyer loves this picture. Is this a tornado? You know, another one, you can't tell. This is west side of Champaign on June 10th. Melinda took this picture. You've got homes blocking her view. Can't tell what's going on there. Looks like a wall cloud or something, but we don't really know. Spotters did report that had a better view. They said there was a wall cloud with this, okay? We did get an EF0 tornado that developed a couple minutes after. This one did some damage, some minor damage mainly. And then a couple minutes later, another EF0 developed. That one was on the ground even for a shorter period of time. And then the downdraft with this storm created a lot of wind damage near the golf course, knocked, I think, 17 power poles down. And that was not related to a tornado, but related to the line of storms that created this tornado, or these two weak tornadoes. There's that Beardstown storm again. Now here we got one in the distance. We're farther away than the previous picture that I showed you, the first picture. What do you think's going on here? I mean, again, it's hard to tell because of the distance. The person taking the picture is about 5 miles away. We have a not as big of a tree line, but still somewhat of a tree line. But because of the distance, we can't see if anything's being lofted near ground level. Okay. An EF0 or EF1 was in the process of developing. It was in the process of forming right after this photo was taken. What about this one? Tornado or funnel cloud?
Funnel cloud.
Funnel cloud. Got a funnel cloud. That's debris being lofted in a field. Very beginning, right there. It does. It does. That's a tall tassel. It goes up to here. Yeah, there is a cornfield there. Yeah. But what was happening here, Jesse took this picture again. She sends us a lot of great stuff. There was rotation that was developing just to the left of the funnel. This was a tornado that developed between Rantoul and Gifford last year on June 26th. Interesting storm. I'll show you a little bit more of that later. It was basically the only storm that produced anything that night in the Midwest. No watches. Warning went out after we got reports of this stuff, but we were not anticipating tornadoes, I'll tell you that much. But these things crop up every once in a while. So yeah, the corn is in the way, distance about 2 miles. So we are seeing some debris being lofted about 2 miles away. An EF1 tornado developed. Right after that tornado developed, it hit an outbuilding, hit a property, and did some damage there.
When you're out in the open, how do you even know what the approximate distance is?
Good question. We're going to talk about that in a moment. No, that's a great question because it's extremely difficult to judge distance. Okay, but we're gonna cover that here. But yeah, keep that question in mind. The other thing, scud clouds, or as we like to call them, scary-looking clouds. A lot of low-hanging clouds with storms. You get these all the time with storms. We had here what looks to be kind of a wall cloud. That thing was changing shape, moving around. No rotation was reported with that. Same thing with this one. Love this picture. We got this picture and I looked at that and I thought, man, that's a nice looking wall cloud there. Well, then the guy who sent us the picture said it looked like this for maybe 30 seconds. And then it was breaking apart. There was no rotation whatsoever. But if you just happen to just walk out the door and see that, you'd think, oh my gosh, that looks like a wall cloud. It's in the right place. You got the rain here, rain-free base here, so you're in the updraft area. That looks like a wall cloud. If you're not sure, just take a moment. Watch it. Do you see any rotation? What's happening with that? In this case, the spotter watched this and said, yep, this was changing shape. Didn't report a wall cloud, thank goodness. So again, a lot of low-hanging stuff, especially late evening when it's kind of backlit and things look dark and ominous. Sometimes they look like funnel clouds and that type of thing. Speaking of which, and rain shafts are another challenge that you're going to have to deal with. This is Interstate 55, getting into McLean County. Look at that. We call that virga, and if you're not familiar with that term, virga is precipitation that falls from the cloud and it evaporates before it reaches the ground. Now in this case, it's got this whitish look to it because these are basically ice crystals, okay, snowflakes, concentrated in a narrow band, falling from that cloud, but the air here is so dry, you know, in the lowest few thousand feet of the atmosphere, that it just dries up before it hits the ground. Or maybe one or two get through and it's like, oh, you know, a sprinkle, or was that a snowflake I saw, or whatever. Okay? But sometimes the streaky nature of this virga can look like a funnel cloud. So as a spotter, you might be called, or you yourself may see this and go, oh, okay, what are we dealing with there? First of all, do you see any rotation? Does it have this streaky look to it? If it does, then you're not dealing with a funnel cloud. Here's another example. This is rain coming out of a shower, or coming out of a cloud, I should say. Again, very dry, not reaching the ground, maybe a sprinkle or two, that's about it. And untrained eye looks at that and says, that could be a bunch of funnel clouds, you know. So again, watch for rotation. In this case, if it's all downward moving air, that's truly not a funnel cloud. Rain shafts, again, particularly early in the morning, late in the evening when they kind of get backlit by the low angle of the sun. You can see the rain coming down through here, and there are very, you know, well-intended people see this kind of stuff, and these are the public reports of a tornado when they see these kind of things. I like this picture. This is from around Springfield, I believe. Real nice cloud structures here. Rain coming out of here, kind of that greenish look. But concentrated areas of rain reaching the ground. Roll cloud. We were just talking about this at the break with a gentleman who came up here, talked to me about these things. He had a great description of a roll cloud, and there's one that we saw last year. It literally is, it's rolling, okay? It's like a rolling pin. What this is this is from an old line or group of storms. It's basically the front edge of the storm that has separated itself from the main storm and gone out and rolled because of the wind shear that's out there. The outflow with the storm, which means there's some cooler air with this directly behind it. If the storms are still intact, sometimes they're not, but if they are, they're several miles behind this. Okay, these go quite a ways out, and you will actually see that cloud roll. Kind of a forward to back kind of rotation. Unfortunately, some people that have not been through spotter training and they see stuff like this, and we've actually had people report this as a sideways tornado. Literally. I mean, you would not believe some of the reports we get. But sideways tornado. No, ma'am, it's just a cloud. It's good. So you can get some brief gusty winds with that because it is with an outflow, so the farther out it gets from the parent thunderstorm, the lighter the wind is going to be, but it's a fascinating looking cloud. Another challenge, especially if you are dealing with a tornado, is what we would call these non-routine tornado presentations. In other words, we already talked about the high precipitation supercells, tornado shrouded in debris, or your very large, that is a wedge tornado. That's a Joplin, Missouri tornado. At least a mile across, if not more. That does not look like your typical tornado. You see that coming over the hill or over the horizon coming toward you. Most people are going to look at, what is that? That's a terrible storm. They don't realize that that's a wedge tornado coming toward them. Bad contrast. Look at this image here. There's a tornado right in here, and when we actually played with the color on the image, then you could see it. Now, when you're out in the field watching this, you can't adjust the color unless you quick get a picture and then go on your digital device and you're looking at it trying to, change the color. But we recommend that to try to cut down on the distance, especially because there's a lot of humidity in the air, particularly later spring and summer. It can be difficult to see things in the distance. This is not like out in the plains. When you're going to spot storms out in the plains and you can see tornadoes 20, 30 miles away. No, here in Illinois, if we can see them 5, 10 miles away, we're doing really good. So have a pair of binoculars. That might help cut down on some of that. Spotting at night. Turn that down a little bit. That's the tornado going through Taylorville on December 1st. Kevin Radley took this video, very good video. Want to note too, he's about 2 miles from the tornado. Here's your tornado right here. You can see the power flashes as it's going through the city. But spotting at night is a very dangerous thing. Unless you really know the structure of the storm, let's turn it down a little more. Unless you really know where that storm is tracking with respect to where you are, I do not recommend being out at night, okay? Spotting at night from a secure structure, your home, where you work, where you quickly duck in and take shelter, that's fine, that's one thing. But being out mobile in a vehicle at night is a very dangerous proposition. Here's the Rantoul tornado. This is one of these situations that comes up. We haven't talked about this in the past, but it's something we wanted to bring up to the spotters this year, because sometimes we hear, we had a tornado, there wasn't even a watch. They have a tornado watch, no severe thunderstorm watch, didn't have anything. What's going on? It went right to a warning. I didn't even know I was supposed to be activated. Once in a while, that type of thing's going to happen. Okay? Watches for tornadoes and severe thunderstorms issued by the Storm Prediction Center are for larger areas, longer lived events. So we're talking, several hour events. Most watches are like 6 to 8 hours for half the state of Illinois and maybe eastern Iowa and northeast Missouri. It's not for a small area, but every once in a while we'll get a thunderstorm that will just have the right ingredients to produce a tornado, produce large hail, produce wind gusts, and there's no watch out there. The only thing I can tell you as a spotter is these things happen, and be alert, especially if you see things that they don't just look, that storm doesn't look right, and especially if you start hearing the National Weather Service is issuing warnings for a particular storm. Again, this one thunderstorm, that was the only show in town that night. That was it. Nowhere else in the Midwest did they have anything. It was just this one storm produced this tornado that tracked, I think, about 4 or 5 miles or so. Came awfully close to Gifford, just to the west of them, east of Rantoul. We'll see another picture of this a little bit later. So these are difficult propositions, but it is something that we have to deal with from time to time. So as far as being aware and being prepared, here's our tornado climatology going back to 1950. We show this every year, we update it, and even though we update it, it looks almost identical. Increase as we get into April, May, and June. That's our peak tornado season, and I'm very careful about talking about stuff like that to the public because they see that and they go, April, May, and June, that's when I need to pay attention, and I can just drop my guard the rest of the year. If we look at the stats just for the last 10 years, we see something like this. June, May, April, February. December, and then March. And then November. Okay? So what we're seeing here is over the last 10 years, we've had this shift to a lot of tornadoes occurring in the cool season. I don't know if this is a long-term thing that we're going to have to deal with, or is this just a short-term blip, a trend that's occurred, and we won't see this again for decades. I don't know. But it's something that we got to be aware of, and just keep in mind that tornado season in Illinois runs from January to December. Right? It's all year long. I mean, we've only had 4 tornadoes in January, but they were pretty nasty ones. But at any rate, we get tornadoes all year long. So we really don't want anyone to be surprised when we get this February tornado outbreak. Okay? By time of day, again, we see a similar thing we've always talked about. Late afternoon and evening. Yes, 3 p.m. to 8 p.m. is the peak time. The bar chart here in red. But the other hours, yeah, we can get tornadoes at 10 o'clock in the morning. We can get them, Washington EF4 tornado 5 years ago was 11 o'clock in the morning on a Sunday, right? In November. We get tornadoes at night. In fact, local nighttime hours, about 25% of all of our tornadoes occur when it's dark. So, again, something to keep in mind. It's not just late afternoon and evening in April, May, and June. Our severe thunderstorm wind season, same thing, wind and hail. Wind is in the blue, hail in that magenta type color. It peaks in May, June, July for wind, April, May, and June for hail, but we can get it any time of the year. We have our maximum here because the conditions are just right, late spring, early summer. But we also tend to see kind of a little mini max in October, November, December. Now I'm gonna answer your question here, or at least partially. Here's one thing you can do ahead of time. If you spot from a particular location, try to look around, notice things around you. You've got trees, maybe you got cell towers, a radio tower, whatever, there's a water tower, there's a grain elevator somewhere. How far is that from where you are? It's hard to judge distance, right? So the best thing to do, look at where your location is or where you spend the majority of your time. go to a program like Google Earth and you can measure. If you don't have that, then get in your car and drive to try to give you an estimate as to how far away is that from where you spot. Now, there's another method too that you can use, and we'll get to that here in a few moments. But this is one thing you can do ahead of time. So, again, know where some of these features are distance-wise away from you. Communications device, essential. I mean, almost everybody has some type of mobile device, whether it's your iPhone, your Android, whatever you got, your tablet. Most people have those things. If not, you've got maybe a laptop or a PC at home that you can use to look at some things. Ham radio, still very important to what we do. Getting reports through ham radio, through other radio networks, okay, through like a Starcom radio network with emergency management officials or law enforcement. So whatever you have at your disposal, use that to report, okay? Another thing, and you saw we're putting a lot of radar images in here, trying to show some of these things with radar. Have a radar app on your smartphone or your tablet. Have your location turned on, especially if you're spotting. And if you have one of these radar apps, there's some popular ones out there: Radar Scope, Pickle 3, Weather Radar Pro, Radar Omega. There's a bunch of them. Go to the, I've got an Android, so I don't know what Apple people use, but the iStore or whatever they call it, I don't know. Apple Store, thank you.
App Store.
App Store. Got it. Okay. Yeah, or go to the Google Play or Google place and look for these. Do a search. Radar, weather radar app. A whole bunch of them will come up. Pick whichever one you think looks good. But here's what can help you when you're looking at storms. If you got your location turned on, the radar app will have your location on there, and then you can see the direction and the approximate distance that storm is away from you if you're out in the open. It's a huge help. Huge help to you because it's going to keep you safe. You'll be able to judge better the distance the storm is away from you and what direction it's moving. But also it's going to help us when you report for saying, look, this storm is moving in this particular direction and it's this far away from me, okay? I already mentioned binoculars, having a weather radio to hear some of the alerts that are coming out, and have that safe shelter identified. Somewhere that you can access 24/7. Not like, oh yeah, there's the restaurant or this gas station nearby, I'll just duck in there. Oh crap, they're closed. I mean, you got to know somewhere you can go 24/7. The other thing I want you to know about, that on your smartphones, and maybe you've already experienced this, when the National Weather Service sends out a tornado warning or a flash flood warning, you're going to get it on here. You don't have to sign up for it. It's not a special app. It comes with the phone. Cell towers send out broadcasts. Even if you're traveling, the broadcast goes out from the cell tower. Your phone receives it. It's a loud alarm. It alerts you. Tornado warning for your area. Get more information is really what the message says. Typically, only if you're in that area, that polygon, that area that we draw that says here's where the worst part of the storm is, that's when you're going to get that warning. If you're outside of that, your phone's not going to alert you. So, if there's a case where only a portion of an area is in the tornado warning, if your phone didn't go off, you're not affected. You're not impacted right where you are, okay? So it's a good way to get the information, but I want to let people know that they're getting that, because sometimes people act surprised when their phone goes off. Tornado warning, I didn't sign up for anything. It's part of what's called IPAWS, which is FEMA, National Weather Service, and the FCC, and all the phone providers, getting that information out to you. Okay, some other things you can do. Check out on our webpage, check out our Skywarn Spotter training page. I got the handouts here at the front table. If you didn't grab one there at the break, grab one on your way out. All the web pages are on there, but if you go to our Spotter webpage, we got a section on there called Spotter Resources. You can go on there. There's additional stuff you can download, training that you can take, online training classes, YouTube videos of this spotter class that will talk about certain features. Maybe you forgot everything I told you about wall clouds and you want to go back and review that. Short YouTube video, we'll review that. We have an updated spotter briefing page at the very bottom of our web page. Go to the bottom left, spotter briefing page. You'll get something that looks like that. During the convective season, you hear about thunderstorms in the forecast. You're wondering how bad could these storms be. Go to the hazardous weather outlook. Take a look at that product. This is broken up by counties. So here we go. Oh, there's Champaign County, all right, that were included in this one. Slight risk of severe storms, damaging winds and large hail. Tornadoes can't be ruled out. Spotter activation. Now here's what you want to focus on. This is what says the time of the day that we may need spotters in your area. Okay, so west of I-55, 3 to 7, east of I-55, 6 to 9 p.m. Just for in this example. Okay, so check that. We update this 4 times a day. So the Storm Prediction Center puts out convective outlooks. We've got all their products here, links to them to take a look at, or you can zoom into the central and eastern Illinois zoomed in view. There are 6 different categories for convective weather. You've got what we're in for tonight and into tomorrow. Thunderstorms, just general thunderstorms. Lightning, thunder, some rain, that's it. Marginal risk, now we're getting up to severe criteria, very close to it, 40 to 60 mile an hour wind. Wind gusts, typically we see damage right around that 60 mile per hour range or so. So it's right getting up to there. Severe hail is considered 1 inch or larger. So here we're talking hail up to 1 inch, so ½ inch to 1 inch. Very low tornado risk. Rarely do we see tornadoes in a marginal risk. Once in a while we'll see one, but we're not talking like any kind of an outbreak or anything. Slight risk or enhanced risk, now we've bumped this up a level. Now we're coming into scattered severe storms. We're going to have a few tornadoes, 1 or 2 here, here and there, but the main thing is going to be the wind and the hail. Wind damage and some large hail. Enhanced risk, now we're going to see a few more tornadoes. Quite a few reports of wind damage. A lot of downbursts. Damaging hail, maybe up to 2 inches in diameter. So we could have, some supercell activity going on with an enhanced risk. Once you get up into moderate and high, this is the big time. These are the big ones. Moderate, widespread severe storms are likely, long-lived, intense, widespread, strong tornadoes possible, widespread wind damage, hail over 2 inches. High risk, major tornado outbreak. We don't see too many of those, thankfully. High risk, we might see, 1 every 2 or 3 years or something. Moderate risk, we may see those maybe once a year, if that. Enhanced risk, we usually see a couple times, 2 or 3 times a year. Slight risk, we see mostly those. We see those and a lot of those in the marginal risks. We also have a weather story that we update several times a day. In fact, when a watch is first issued, we update a weather story, usually with a current radar, to indicate areas where severe weather might be possible. In fact, I got a video here that kind of helps explain that. I hope. Nope.
Even develop.
There we go.
Whether you're spotting from your vehicle or from your back porch, information about when and where storms are expected to develop, which way they're going to move, how long they're going to last, and other forecast details can help you plan your day and make it easier to react when the storms get going.
So this is an example of one that we put out showing all the counties in yellow are in the tornado watch till 10 o'clock. This is a 4:10 p.m. radar image showing that between 4:30 and 5:30, the red hatched areas here, that's where we're expecting the storms to move or become severe. And then we kind of put an arrow there showing the general storm motion to let people know what, if you're out spotting, what direction do I need to look for these oncoming storms. Any watches that are issued, tornado or severe thunderstorm watch, will be on this map here. You can click on that and it'll You'll see a much bigger image. Go to the Storm Prediction Center webpage. We got lots of different radar displays down in here. But the one I want to point out here is our severe weather products. These are the text products that we issue. So every time we issue a tornado warning, click on that. You'll see the latest tornado warning. You can go back and look at previous versions. Severe thunderstorm warning, same thing with flash flood. Now, severe weather statements, I want to point this out because this is what we use to update our warnings. So if I issue a tornado warning at 4 p.m. and it's in effect till 4:30, about 4:10 or so, 10-15 minutes into the storm, we will issue a severe weather statement updating that tornado warning, saying here's where the storm is now, here's what you can expect with that storm. If something is upgraded to the point where, or we need to expand the warning, we'll just issue a new tornado warning. We don't do it through this statement. Another thing I encourage you to look at is right here, the local storm reports. Either text products there, or if you scroll farther down on this page, you can click on the Storm Prediction Center storm report page. And a lot of these radar apps also, you can plot storm reports. The key thing there is you're getting a history of what that storm has done. So you're sitting here in Champaign County, so let's say storms are coming from the southwest, and you start to see reports of golf ball size hail, and now the hail's 2 inches and it's down around Decatur, or the area is over there and it's could be heading your way. It at least gives you a history of what is that storm doing, so I get an idea of what I could possibly expect as it approaches me. All right, spotter safety. This is number one. This has to be your top priority. Now, I will say, sometimes people will say, I want you to teach me how to chase storms. Okay, we don't do that. Okay, get with somebody else that does that. All right, we don't encourage spotters to chase. It's very dangerous to do. You've got to know what you're doing. You got to be really intelligent about the meteorology and the storms and how they're moving and shaping and evolving to be able to effectively chase a storm. Some spotters might be mobile. Some spotters might be told, go to a particular location, park your car and watch, tell us what's happening on the west side of town or something like that. Okay? Many will not. Many people will be spotting from their home, from where they work, maybe just as they're going along on vacation or something. But you don't have to be mobile to be a spotter. But all spotters need to be alert to the conditions that can change very rapidly with these storms. I mentioned this before, but I want to repeat it again. You've got to have a clear path to safety. Whether it's in a building, getting down into a basement, or the lowest level in the middle of a structure, you've got to know where these are or how quickly you can get to those locations. If you're mobile, you got to know the roads around you, okay? Be careful with GPS. Sometimes, that doesn't tell you that this road is not paved and it's been pouring and now it's mud and you don't want to get stuck in that. Or you're heading down a dead-end road. Definitely don't want to get trapped on a dead end. Spotters have had that happen. And then here comes the storm and it just cut them off and now they have no escape and no road to get out. So don't get caught on that dead end. Don't spot alone. That's a dangerous thing to do. I mean, number one, somebody has to drive, right? Hopefully you're not trying to drive and watch at the same time, okay? That's not safe. Be aware of congestion, construction areas. Again, just kind of have a general overview, especially if you're going to some place that, let's say you're on vacation or something, you don't know the area. Try not to get caught in these areas when there's bad storms around. Look out for emergency vehicles, pedestrians. I want to point out here, shout out to some of the folks that I know that work for the state police. They've had a rough year so far. Yeah, another one?
Another one today.
What is it, 15 now? 15, 16 state police vehicles have been destroyed. Officers injured. I know of at least one that was killed. Today was killed too.
Yeah.
Pulled over to the side of the road, getting hit by people not paying attention as they're driving. This could happen to a spotter or a chaser if you pulled over and didn't pull over far enough. Okay? Pull over way off the road. Now again, when you're spotting storms, you're not supposed to be running any kind of lights on no light bars on your cars or any of that stuff. but put your hazard lights on. At least be visible. But pull way over, get in a parking lot, something like that, so you're not in the way of traffic. Okay, very dangerous being out there on the side of the road. Know your position with respect to the storm. Again, this is where that radar app will help. We got the technology, let's use it. Put the location on there, see where you are with respect to the storm so you don't get caught with another tornado developing or the storm suddenly changes direction. The radar app will help you with that. Don't drive through the core of the storm. Chasers call this core punching, okay? This is very dangerous. Like here's the storm that produced the Washington tornado. This is bad, okay? A lot of large hail up in here. So you're coming from this direction. Not only are you in large hail, you're approaching the area where the updraft is. That could be, the tornado. You could come out of this low visibility, heavy rain, hail, and suddenly there's a tornado in front of you. Same thing here. You don't want to come up through here. You're driving right through the rotation. Or up this direction, okay? This storm was moving northeast, all right? You would want to be down over here. Enough away from that. Got to be careful with being in this area, because remember I showed how the supercells can go cyclic, and this rotation dies out. Where's the next rotation going to develop? Usually off over here. If you're sitting right over here, the rotation could be right over your head, and you wouldn't see it unless you're looking straight up. Most people don't look straight up. So stay away from the core of the storm, or you're going to end up with that. That's pretty much totaled. Or debris flying through the air.
Here's a supercell that's producing a tornado. Based on what we can see in this image, our spotter seems to be in a fairly good position to see the action area of the storm. The storm in this case is moving toward the northeast. The spotter has thought ahead and has an escape route mapped out that will take him to the south and away from the most dangerous part of the storm. This all sounds great based on the picture we see here, but remember that situational awareness means looking at the big picture and having a good sense of what's happening not just with the storm you're observing, but with other storms and everything else around you. So here's the big picture. That escape route to the south doesn't look so good anymore.
Not good.
Safety depends on you being constantly aware of everything going on around you.
Yeah, so keep your head on a swivel, look at your radar imagery to help you make your decisions. Because you can't, there are rules of thumb that say, hey, if this is the only show in town, sure, go this way. Get away from danger. Not if you got another one right there, so you got to watch out. These guys are doing a good job. You'll listen to them.
Keep going. Can you get past those trees? Okay. It's a fast moving storm. Oh wow. Look how fast. You know what? It's coming. Well, we're okay. I think we're okay. Never mind. We can see it right here.
Yeah, just stay here.
Just stay here, we can see it.
Let's cross and come across the road in front of us.
Come on. Pick up, guys.
That's a
Duck left.
quarter-mile wide tornado moving at 60 miles an hour.
Duck left. What do you think?
Very fast movement. Not every tornado moves that fast. A lot of them move about 30, 40. This one was moving 60. At times it was even moving faster than that. So they're in a good position, okay? It's moving kind of parallel to, or perpendicular I should say, but they stop. They decide not to go through this intersection. They realize it's going to cross the road in front of them. They had an escape route. They could have ducked left as they were talking about. They could have turned around and went back where they came from, but they had some options there, and they made a smart decision not to go any further. They're close enough. Well, here's the opposing. Not such a good position.
You're really close to this.
starting to get some debris.
Across the road, directly in front of us. We're good.
Are you sure? I don't know.
Right into the vortices. Get those vortices.
I want to stop the video right there. It's pretty much done anyway. You get the picture here. Really close, way too close. No decision was made to stop. The only escape was to pull over or to just turn around and go back. There's no roads that cross. This is Illinois Route 100, if you've ever been on that, right on the Illinois River. Not the best place to be spotting or chasing. See this right here? That's the windshield of the car. Okay, how's the driver getting that image? I want to know. Do they got a stick? They probably have a stick of some, or a really long arm? I don't know. So we tell people, and you probably heard this a million times, so we're going to keep talking about it, you got to get into a sturdy shelter, get down to that lowest level, and then cover up. A lot of the injuries in tornadoes are head injuries from debris falling and hitting people in the back of the head or on top of the head.
You heard about the bicycle helmet?
Yeah, yeah, yep. There are some people that get to put the bicycle helmets on. I talked to a guy. He said every time there's a tornado, he gives his wife his motorcycle helmet. You know, kids play football. They put the football helmet on. Yeah, anything to protect your head, because that's where a lot of the injuries are occurring, from debris falling in as homes are collapsing. If you're outdoors, it's not a very good situation. I mean, if you're outdoors, you got to get to some kind of indoor shelter, but maybe you're out in the middle of nowhere, there's no indoor shelter to go to. As a very last resort, you got to make a decision. Do I lie in the ditch or do I stay in my vehicle? That's a hard decision to make. If you can get into the ditch, if the tornado's bearing down on you, if it's that close to you, or if there's some type of drainage culvert that you can get into to protect yourself, great. Just know that cars, automobiles, it doesn't take a very strong tornado to flip a car, okay? An EF1 tornado, which we get a lot of, can flip a car. It can pick up a car, okay? I've seen EF1 tornadoes roll pickup trucks. So it doesn't take a strong tornado to roll a vehicle. Here's video November 17, 2013. Near Tuscola, Illinois, I-57 underpass. This is an EF3 tornado that came through this area. Right there. Debris starts flying into the vehicle. These barrels are getting beaten. Oh. Oops. Yeah. Tree limbs, portions of trees flying. These barrels didn't stand a chance. Yeah, very dangerous situation here. And getting into the underpasses, again, the wind can increase in there and it can cause severe issues with your vehicle. Flash flooding. This is any type of flood where the water is going to be rising rapidly in a short period of time, minutes or hours. We have a moist soil right now. If we got a bunch of heavy rain, oh look, there's a road close sign. That happens a lot, unfortunately. I'm in a truck, I'll get through. How do you know the road is still there? Well, you don't. These guys aren't going to take a chance. But if you get 1 to 2 inches of rain in about 60 minutes or less, that's a real good guideline for flash flooding, okay? Especially in urban areas. We're seeing a lot of urban flooding. I was told at one time by a wise person, supposedly told me, we never get flooding in Champaign. Or Champaign County. And I said, well, what about all those underpasses? And oh yeah, those always flood. People know about those. But we don't get flooding out, you know, like out in the county. And I know John would beg to differ on that one. So yeah, we can get flooding just about anywhere. You don't, Sydney, yeah. Yeah. You don't have to have a wall of water coming down a canyon to be considered a flash flood, okay? It's like this kind of thing, right? A lot of urban flooding.
Running late. When it's happening, blocked by water crossing the road. It doesn't look that deep, so you decide to drive through it. Bad decision. And it may be your last.
It's only the end of March. We've already had 24 fatalities across the United States from people driving into flooded areas in various places. Every single year this is happening. And in fact, flash flooding, vehicle-related flash flooding, more people die from that than in tornadoes and lightning strikes, oftentimes combined. So this is a significant situation. It's severe. This one here, school bus, Texas. There's a sign, it's kind of hard to see, it was right there, it said road closed. Apparently the bus driver didn't see it. You know, a school bus is a pretty large vehicle. You'd think you could drive through some water. It doesn't look too bad on this road. In fact, this particular morning in October last year, there were some severe storms in that area. Tree limb down. We're just going to drive over that. It's in a bus, right? Here's, okay, the creek's flooded. Are we slow? We're not even slowing down. Okay, here goes the bus. But he's in a bus. He's going to make it, right? No, he's not going to make it. Look what happens here. It's starting to wobble a little bit. Now it turns. Yep. The creek takes him downstream. He's basically a big yacht right now. This was early in the morning. This was like around 8 o'clock in the morning on this particular day. And there's more of this video. It's basically just the bus going backwards through this stream. Yeah. Here's the thing. Bus driver, yeah, he's in a serious situation. So he's got a radio in the bus. He radios for help. We're going down this stream. He knows the stream he's in, so he tells them where they could find him. He's got one kid on the bus with him because he's just picked this kid up. So rescuers come out. They get the guy. They get the kid. Right after they got the guy, he was arrested for endangering a child. The next day he was fired from his job, thank goodness. We need more and more and more of this type of thing. We need laws on the books, and I know there are some communities that have this. My hearts go out to the first responders that have to go out and get people that do this kind of thing. Because now you're putting yourself in danger trying to fix somebody else's stupid, you know, especially that. I mean, some things are hard to, oh, how deep is the water? I don't know, and they go and they shouldn't have. If there's a sign that says road closed, yeah, I mean, stay out of there, definitely. And then you get this kind of thing. I mean, this is in Woodford County, Illinois. The road washed away. The guy comes down the hill here. It's night. This was the next morning, but night, he couldn't see that the road wasn't there. Right down in. Very dangerous situation. Wisconsin, July of 2016, a lot of flooding, tearing roads up. Missouri, same year. We're wet this year. There's already a lot of flooding going on in the Mississippi River. You heard about all the flooding in Nebraska, parts of Missouri the last few weeks. This could very well be a nasty flood year in the Midwest. So keep your eyes out for this type of thing. So the bottom line is, don't go across the covered roads covered with water that's flowing, or any kind of bridge that's got water going over it. don't walk into the flooded area unless you're evacuating. Somebody tells you got to get out of this area, then safely try to get out of there. There's a lot of nasty stuff in the water. Lightning. Lightning almost out of the blue. Right there. Video taken from the police cruiser here. He's just driving along and dash cam on, and there's lightning strikes right in front of him. And then one of my favorite lightning videos recently. This was brought to you by the Canadian Northwoods, I believe. Yeah, that was pretty surprising. The tree not only took it, but the rest of the tree came down with it. And you get that with some of these lightning strikes. It's not just the strike. You'll get damage or debris from lightning. But I got a question for you. What was not happening in both these videos? Rain. It wasn't raining. You get quite a bit of lightning in areas where it's not raining, either as the storm's approaching out ahead of the storm, or more likely on the back end as the storm's moving away. The thing we know about this lightning too is a lot of lightning we get with storms is negatively charged. A lot of this lightning is positively charged. It's got a lot more charge with it. It's hotter, and this is the kind of lightning that catches people off guard. Because too many people think, oh, it's not raining, I can go back outside, storm's gone, right? No. You really need to stay in your safe shelter at least 30 minutes after the last rumble of thunder, when that storm is moving away from you. As the storm is approaching, once you hear that first rumble, you got to get indoors, get to some safe location, either in a secure building, or in a vehicle with the windows closed. Keep the windows closed. Lightning can enter the vehicle if the window is open. Golf course lightning. You ever see Caddyshack? Man, guy had the great golf game going and he gets struck by lightning at the end. And so a lot of golfers have been struck by lightning in past years. But if we look at the last 5-10 years, the one activity that has surpassed that, fishing. People out fishing, whether you're on the shore, in a boat, on a dock, whatever, struck by lightning. Okay? Fishing and riding bicycles in a thunderstorm. So those are the two things we've seen increases in lightning injuries and fatalities just in the last 5-10 years. So anywhere outdoors is unsafe, especially by trees. We think we got that message across by now, but every year there are still people that are killed standing under a tree. Open doors. Lightning will come through a large building. If you're in that large shed, get the doors closed. Keep lightning from entering the building. Picnic shelters aren't going to help you, and like I said, the open window on a car is not going to help you either. With thunderstorms, this is where your situational awareness comes in, because when you get wind starting to increase in a storm and your visibility is getting low, it's raining, and you have a hard time seeing, man, I got to pull over. Don't pull over next to the power pole, the tree, something that could fall on you, okay? Pull over in an open area. All right, you're much better off in there. Go into parking lot, away from, light fixtures and things like that. I like what these guys do in this video here.
This is cool, man.
That's cool. They're in a downburst, okay? This is what it would look like to be in a downburst with that 60 to 80 mile per hour wind.
Look at that.
It's kind of, just horizontal sheets of rain.
It's here. Why are they driving in that?
So the thing that they did, which was it was subtle, But they're going down the road and they realize the wind's picking up, so they turned so that the wind would go parallel the length of their vehicle and not hit them broadside and flip them or push them into the ditch, right? Very smart move. If you notice the wind picking up, if it's starting to hit you on the side, you know, make a turn left or right to get parallel. Hopefully, with, you know, it'd be better with the wind. The way they went, the wind was coming at the rear of the car. That's the best place to be. Last section we're going to talk about here, spotter reporting. You don't want to keep it to yourself, obviously. You got to tell somebody, all right? And we're going to cover this again. We've not talked about this in the past. A lot of this was based on feedback we got after December 1st with that outbreak of tornadoes. When you're reporting on features not located right where you are, please give us the direction and estimated distance of whatever you're observing, okay? Here's an example. Now this guy didn't do this, I'm just putting this as an example. Tornado in the distance. He's near Poplar City, Illinois. Do not report there's a tornado in Poplar City. It's not in Poplar City, okay? It's in the distance, okay? The better report would be, I am near Poplar City, I see a tornado in the distance to the west. Now, if you have your radar app that the guy at Spotter Training told you to get, and then you can measure, right? You look at the radar app and you go, oh, my location says I'm here, the storm is over here. And if you're able to measure that on your app, you can say, oh, that's about 8 to 10 miles away. Report that. If not, again, still, just say, I'm near this location, it's to my west in the distance. That is an excellent report, okay? With this particular tornado, we thought we had half a dozen tornadoes because we got a report from here, 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 and they all said the tornado was in that location. Okay? That's not where it was. It was here. So help us out, help out the responders, help out the emergency management folks with a little better report. Another example, we're back to our Rantoul tornado. Okay, now again, she didn't say this, she sent the picture. Thanks, I appreciate the picture, but there is not a tornado at the Walmart in Rantoul, okay? She's at the Walmart in Rantoul. The tornado is not there. Now again, she didn't say that, but I'm just using this as an example. A better report would be, I am at the Walmart in Rantoul, I see a tornado to my east. Okay, that would be a very good report. Even better would be, I'm here, I see this here. Now, I don't see any features there. That was a terrible storm. No, I don't know what's going on there. We have very few reflectivity features. We have very little in the way of rotation at the lowest elevation angle the radar can go. But we had a tornado, so it's in there somewhere. Sometimes radar can be kind of difficult when you're looking at it. So, but again, try to give us some bearing at least, so we know that, okay, we're dealing with a tornado here. Because with another storm up here, if a spotter up here sees this one, we're going to think, well, are they talking about that one or this one? It takes extra time to wade through all the information. So help us out with that. As far as what to report, if it spins, call it in. All right? Tornadoes, funnel clouds, wall clouds, all those things have a high priority. Flooding. Still using your picture, Pete. Sydney flooding. How deep? The water flowing, what roads? This is really critical for local officials to be able to get a barricade up or something like that. I know a lot of times barricades don't work, but you got to get them out there to try to keep most people out. Wind gusts. It's hard to estimate wind speed. Again, your real small twigs, you know, inch or less in diameter coming down, pruning the trees, probably talking 40, 50 mile an hour winds. Once you get into the 50, 60 range, now we're starting to see some of the bigger branches. And now when you got uprooted trees and stuff like that, it's usually greater than that. But you got to keep your eye out on what you're dealing with here too. For example, if I had a 70 mile an hour wind come through right now, I probably wouldn't have as many trees down because there aren't any leaves on the trees right now. the wind would go right through the branches. Probably prune out some branches, but if we had leaves on those trees, we'd have a lot more trees falling, a lot more branches coming down. If it's been wet, if it's been raining every day for the last 5 days, the soil is wet, you're going to pull up the root ball of some of these shallow rooted trees. You may not even have a 60, you may not even have a 50 mile an hour wind do that. So again, just try to report what you see. We'll figure out the details on it. But be as descriptive as you can. Hail, if there's a common object that can describe it, that would be great, okay? Golf ball, remember, that's your supercell kind of limit right there. Tennis ball, baseball, etc., up to grapefruit or larger. Strangest hail report I ever saw several years ago, Storm Prediction Center. Somebody reported dog biscuit size hail. Now, would that be a milk bone for a large dog or a small dog? Or I'm surprised they let that one go through, but that's a great report. Dog biscuits. So, who you're going to report, I'm a trained spotter, okay? If you just start yelling into the phone and telling whoever you're talking to, they're going to assume you're probably just the general public. Your report's going to hold a little more weight if you say I'm a trained spotter, okay? What you've witnessed, be very specific. When it occurred. Remember, your safety comes first. If it is near you, maybe you had to duck into shelter and you couldn't call for 10 minutes later. Try to subtract that time out if you can and say, okay, 10 minutes ago this happened. And then where the event occurred. Again, being specific as you can, using that radar image if you can to help triangulate where these things are occurring. As far as who to report to, if you are an EMA as the volunteer, chances are your reporting agency has some type of rules as far as how they want you to report and that type of thing. Is there anything you want to say about that, John, for Champaign County EMA?
Contact whoever their local network is. It could be the village, it could be us.
Okay. Okay, so whoever your local contact is in the village, the county EMA, 911, that type of thing. All others and Skywarn spotters, first, if you know there's any injuries or major damage, you call 911, okay? Get that report in because those people need help right away, more so than what you've witnessed. Then report, if you're not reporting to EMA or 911 lines are so busy or whatever and you can't report that tornado, funnel cloud, whatever, report directly to us at the National Weather Service. There's a number of ways you can do it. They're all listed on that sheet that we have there. Here's our email account. If you take pictures, send me your pictures. I'll put them in next year's spotter class, okay? If we have any severe weather. Facebook, Twitter. I will say something about social media. It's going to get your reports in quickest, and I want to tell you, thank you to the spotters and chasers that were out there on December 1st that put stuff on Twitter or on Facebook as it was occurring. Huge help to us at the National Weather Service because we could see as it was happening what was going on. There are some folks that are just excellent about doing that. Thank you for doing that. And you know, I find out a lot of the people that are doing that tend to be from around Champaign County here or Eastern Illinois. So you guys are doing a great job with that. So keep that up. We see that stuff in social media. We follow you guys. If you put a hashtag ILWX, ILWeather, we're going to see it. Just as kind of a brief thing to mention here, even if you see something the next morning, you know, stuff happens at night, light of day, oh my gosh, there's more trees down than I thought or whatever, report that, even if it's several hours or a few days later. Healthy tree limbs, this is ones we often get questions. We'll call and we'll say, hey, do you have any damage? No, just a bunch of trees down. Okay, that's damage, right? They're thinking property damage, like the roof's intact, the barn is okay, but there's trees. That you still, if they're healthy, you still had to have a strong wind to take those down. So report that. If you are not an EMA as the volunteer, and I encourage you to volunteer with the local emergency management. But if you want to be a Skywarn spotter that reports directly to the Weather Service, go to our spotter training webpage, our spotter page, go on spotter resources, scroll all the way down to the bottom, and there is a Skywarn logo down there. Click on that and a form will come up. You put your information in there, and we don't use spotter ID numbers anymore, but we'll take, you put your name, your address, phone numbers where we can contact you, that type of thing. Then what we're going to do is we're going to look at the people that have signed up for that, and we're going to look at the sign-in sheets that we got from the spotter training class you said you went to, and if you're on that sheet, then you'll be in our database. If you're not on that sheet, well, then you're just trying to be in our database, and I don't know if you've had training or not. So, select that and register that way. You got to be at least 18 years of age. I don't think we have too many kids in here, but we will cross-check your name. I already mentioned that. So, a few final words. First, this video. More of an audio than a video. Come on. Hello. There it is.
But even the most advanced radar technology can't reliably tell us exactly what's happening on the ground in your community. Radar algorithms give us an idea of the hail size in a thunderstorm, but the only way we know for sure is through reports from someone on the ground. Same goes for tornadoes. Radar shows us that a tornado could be occurring or may be developing, but we need to get verification from someone actually observing the storm. And storm spotter reports do more than just verify what radar is showing. Research tells us that people are more likely to react to warnings if we give them details about what's actually occurring, versus just saying radar indicated. Spotter reports included in warnings and statements can help people in the affected areas make better decisions to stay safe.
So that is really the most important part of that video, is what he said there as far as your reports, people using to make decisions to keep community safe or decide, okay, are we going to activate our spotters in this particular county 50 miles away or whatever. All your reports are critical. So in summary, stay safe out there. If you're not safe, you're not going to help anybody else. Spotter reports are a vital part of what we do in the warning process at the National Weather Service. As he said, people are not going to take shelter, a lot of them, unless they have that real-time spotter report in there. So that report is helping people make the decision that they need to go to shelter. For those of you that are new, about roughly 30% of you, this is your first crack at spotter training. We talked about a lot of stuff today. You may not remember every single thing I talked about. So I encourage you, if you have an interest, take more classes. I recommend, if you want to come every single year, that's great, at least every other year to update. And go to our spotter training webpage and download that booklet that we have for your device. We all got the YouTube videos on there, so there's a lot of different ways that you can get information to learn more about this really important topic. So, I want to thank you for spending your time with me this evening for a couple of hours. Be safe out there. There's all the places where you can contact us or report to us. Grab one of the handouts if you didn't and get one yet. And I will be around if you guys have any questions. If you want to ask a question right now in front of the whole group. If not, I'll be here for several minutes.